Welcome to today's activity, which aims to popularize scientific knowledge. Our topic for this session is self-assembly of cellulose nanocrystals. This story will start with how this CNC is extracted from the most abundant and almost inexhaustible natural polymer and self-assembles into highly ordered structures, which exhibit the fascinating iridescent color. Cellulose nanocrystals, abbreviated as CNC, are the derivative of cellulose extracted from plant fibers. Such CNCs are widely existed in the cell walls of these plants with tightly packed structure, forming the basic structural component to protect the cells from microbial attack. After extraction and processing, CNC undergoes evaporation-induced self-assembly. This is a natural, spontaneous process where CNC organizes itself into a highly ordered structure without external intervention. Self-assembly of CNCs is determined by a range of factors like temperature, pH value, and relative humidity, etc., and any slightly variations in these factors can significantly alter their final structure. The structure of self-assembled CNC is not only unique, but also possesses various physical, chemical, and optical properties. Physically, CNC demonstrates high mechanical strength and thermal stability. Chemically, it is biocompatible and adaptable. Optically, CNC exhibit fascinating iridescent color via the interaction with visible spectrum, making it widely applicable in many fields. Given its unique optical properties, CNC can be used in test papers and sensors for disease diagnosis. In the field of biomedical science, it serves as a material for antigen detection and can also be used to monitor environmental changes. We will show a video demonstrating the color change of CNC materials when exposed to water. This is not only an example of CNC application, but also visually displays its potential. This vessel contains sodium cellulose nanocrystal self-assembly material. Observe its color under the light. Now we are adding distilled water, gradually wetting the entire surface. Notice how the color of the material changes with varying humidity, demonstrating its unique responsive properties. For this episode, we have specially invited Yuchen Zhu, a doctoral student from the University of Manchester, to provide an in-depth introduction.
Question 1. Could you please elaborate further on this subject for our understanding?
That is why accessible source you can use for the extraction of the CNC. And since it has a great potential in self-assembly because it has the rod-like structures they formed during the self-assembly. These formed highly organized structures can interact with the light, so it gives structure color. So that is different from the dyes or pigments. So that is the time-dependent bleaching effect it can produce. So if you keep the structure intact, so this color will never go despair.
Question 2. What are the current challenges faced in the field of CNC self-assembly technology?
Maybe you can just wonder what is the biggest challenges to this CNC self-assembly. As you know, so this process is just sensitive to the factors including the pH, humidities, or additives. So you have to tune these factors to get final structures. Once any slight change on these factors, so the final structure would be changed.
The last question, What are the various applications of the CNC self-assembly materials in current research and industry?
What the CNC can be used in. So like we said before, this CNC can form the honey oil structures, which can give the structure color. So I think that it can be used in the sensing applications. So if you use it in the moisture environment, so the voids between the structure can be filled with the humidity, so the color would be red shade or blue shades. So if you have this these samples in medical applications, I think you can make some the modification on it, like the antibodies, so that can seek binding the antigens. So once they achieve binding to themselves, so they can shift color. So that is one of the applications in the medical application.
The art of self-assembly, harnessing CNC for a sustainable future. Cellulose nanocrystal self-assembly opens new avenues in sustainable materials. Combining biodegradability with advanced functionality, research is advancing their use in biomedical applications, balancing eco-innovation with industrial scalability. CNC self-assembly is key to pioneering sustainable solutions. This presentation was brought to you by Jia Miluo and Xiaoyang Zhu, postgraduate student in biomaterials at the University of Manchester. Thank you for watching. We hope that today's scientific popularization has given you a deeper understanding of cellulose nanocrystal self-assembly. We look forward to sharing more scientific insights in our next episode.